This video is going to talk about the normal distribution. Notice I'm keeping the copy of the notes on the same page as the one for the hypergeometric. To make sense of these problems, you're going to need to go ahead and get out the normal table. I uploaded one copy of the normal table, but it's also in the back of the textbook. You can find it. So to start this, what we're talking about is something we're going to use with our continuous random variables. So we've done lots of examples so far with everything that's discrete, but now things that are continuous are going to be x, like the volume of liquid, units of time, things like weight that's measured. So all these variables that we're going to measure for our data, but these are all the ones where, remember, it's continuous when values in between values still make sense. Okay, so in order to work out any of these problems with the normal distribution, what we're going to need to do is first just learn how to use the table and solve a general problem with the table, and then we'll finally be able to use it. So let's just look at a picture of a bell curve for a minute. We know a little bit about a bell curve because we've talked about going out standard deviation intervals from the middle. But the bell curve we're going to think about right now is a really basic one, which has a mean of 0 and it has a standard deviation of 1. And this one is called a standard normal. And this is the one that's depicted in your normal distribution chart. So if it has a standard deviation of 1 and a mean of 0, it's a standard normal. And we pretend, or we name the random variable z is a standard normal random variable. So instead of using x, we're just going to use z. So for what we're doing right now, it's not going to be applicable to anything else just yet, unless that particular thing happened to be a story where the average was 0 and the standard deviation was 1. So we're starting with figuring out the table. So let's take a look at if z was equal to 2.00. Okay, so z equals 2.00 is a particular value. Now, the whole area under a normal distribution is going to give us the chance of something happening. So instead of before, like x equals 1 had a particular probability, now we're going to have to say things like, what's the chance that x is between some range? So if you look at your normal table will have, what we'll need to do is we'll need to think about a range of outcomes, and then the percentage of the area under the curve in that range will tell us the chance of that outcome. So in particular, if we said z equals 2.00, if you go and look at your normal table, it has columns and it has rows. So the way what we're going to be looking for is we're going to be looking for on your table, I can't show it both at once, there is a row that says 2.0, and then the first column says 0.00. So the columns represent the hundredths of the decimal place. So when I'm looking at this decimal place, it's corresponding to this. When I'm looking at the first 2.0 portion, That's corresponding right here. Okay, so if you look in your normal table, the value that falls here is going to be the probability for the left tail. So when you look at the table there, what you should see is 0.9772. And that means all of that area is 97.72%. So we would say there is a 97.72% chance that Z is 2.0 or below. Now, we can also use this to realize that the rule of complements is still going to work. So if the whole area under the normal distribution is probability and it's equal to 100%, then that would mean I could figure out that chance. So by rule of complements, 1 minus that chance is equal to 0.0228. So there is a 2.28% chance Z is 2.00 or more. Notice I included the 2.00 in both cases because once it's continuous, leaving in the 2 or pulling the 2 out doesn't make a difference actually, because you can just think about between 1.99 and 2.00, there's still an infinite number of possible values. You just keep dividing it in half. So including or excluding the boundary doesn't make any difference on a continuous random variable anymore. Okay, so let's look at just another one. So we're just practicing with the table. So let's find the chance that Z is smaller than a negative 1.02. So my practice is I usually always draw the picture. The reason I do that is, as we just saw, it's like showing your work, and whether you're finding the left or the right tail can make all the difference in how the problem works out. So the middle is 0. I do a little picture of what the standard deviation is over there, because once we change it from a 1, we're going to need to keep track of it. And then I'm going to just draw a negative 1.02 and say what's the chance we're going to get below a 1.02. So when we do that, we're going to go to our normal table and we'll see that the negatives are on the other side of your table. And let's think about the implications of when it says 0.02. This is the 0, 0, the 0, 1, and now this is where I'm going to find the 0.02. And I need to go to the column that says minus 1.0. And so this is the value I need to find for the left tail. And I want to pause. So now when we look at your table and we go to 1.0 on the negative and we go to the 2 column, you should see 0.1539. Sorry, I'm going to redraw that. 0.1539. So this area is 15.39% of the total area. So just to have a practice, you can pause this for a minute and you should try to work out a couple different ones here. I'm going to give you a couple. Find the probability that Z is greater than 1.76. Notice the greater than, you might need to use the rule of complements to work on that one. And then the second one you can practice is find the chance that Z is between 1.76 and negative 1.76. And then after you've worked those out, you can just pause this and start it again. So I'll show you those now. If I need greater than 1.76, when I go to the table, I'm going to remember the table only shows me the left tail. So let's do some exciting colors. So the left tail from my table, if I look up 1.76, the 1.76 gives me 0.9608. And so I need to subtract that from 1, and I will get a 0.0392. That's this area. So that is the answer for the chance Z is greater than 1.76. Now to look at the next one. One thing we need to think about with the normal distribution is both sides are exactly 50%. And that means both sides work exactly the same. So if this side, they're symmetric. If this was 0.0392, then without even using the table, I can realize that that side has to be exactly the same. So if I'm interested in this problem, what's the middle here? Looks like from my color choice, I'm an Oregon Ducks fan, but actually not really. Then when we can do the same thing here. We can say, starting with a 1.0000, I'm subtracting off two different tails that are around 3% each. And so what I'm going to get when I do this problem is that I get, this is 0.9216 is the chance that Z is between those two. So what I'm going to suggest or do this time is I'm going to stop with the normal distribution right here. And what I'm going to say is do the homework problems that are starting from chapter 6. And the chapter 6 ones that you should be able to do with just this section is, this is only section 6.1. And then the next video will start out with what we do for the next section of 6.2. And because we don't get to meet in person, I will also show the work of a couple of the homework problems. And that's the end of this video. Thanks. Hope you're all safe and calm, and I'll talk to you soon.